All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video, where today we're going to take a look at proportional, rational, and literal equations. The literal equations part is something new, but the rest of the worksheet serves as a test prep for you. So let's get started on this. So you have some idea of what's headed your way for next week's test. And along the way, we'll learn about literal expressions. So some of this is going to be review, and some will be new material. First question is m over 5 equals 8 over 2. Okay, so this is just a proportion problem. We're asked to solve this because there's an equal sign, and so we'll use butterfly. Okay, you just draw the butterfly here, and now we'll say 2m equals 8 times 5. All right, well, that means 2m, and that's again 2 times m, equals 40, because 8 times 5 is 40. And to get m by itself, I'll just divide both sides by 2 and cancel the 2's on the left, and I get m equal to 20. Let's move on to number 2. Number 2, we're given n over 4 set equal to 3 over 6. All right, and we're asked to solve this proportion. So we will solve this proportion by doing butterfly. And that gives us 6n. Remember, just as out of deference to the aesthetics of mathematics, we just put the 6 up front, okay? The coefficient goes in front of the variable. Even when it's n times 6, you write 6n. And then we do 6n equals 3 times 4. Okay, and that means 6n is equal to 12. Then we divide both sides by 6. The 6's cancel, and we're given n equals 12 divided by 6, which is 2. Okay. Number 3. Number 3 is new. It says solve each equation. So just take a look at this. This might be something new for you. All right. So I'm going to write it down, and we'll work through it. Okay. So we're given 3 over r plus 1 over r equals, and then medium fraction bar, 6r plus 6 over r squared. Okay? Now, at first glance, this problem seems weird, you know, but notice that on the left side of the equation we have a common denominator. It's just r, so we can add 3 plus 1. And so let's rewrite and simplify the left side here as 3 plus 1 is 4, so we write 4 over r equals 6r plus 6 over r squared. Okay? So, now, what do we do at this point? Well, it's just a proportion, you know, because you've got 4 over r equals 6r plus 6 over r squared. It's just a big proportion. So now let's do the butterfly method and try to capture all this. Okay, I know that color is light, but I don't want it to distract from what's underneath the lines. So now we're going to multiply 4 times r squared, take this slow, equals r open parentheses, indicating distributive multiplication, 6r plus 6, close parentheses. All right? And so 4 times r squared is just 4r squared equals, now we got to distribute the r. And before we were distributing numbers and numbers with letters, now we're just distributing a letter. So what is r times 6r? Well, the 6 just comes along, we didn't do anything. R times r is r squared. So 6r squared plus r times 6 is just 6r. Remember, we write the number in front of the letter. Well, now what? Well, now we combine like terms. And we only have one pair of like terms, and that's the r squared. Okay? So we subtract from both sides 6r squared. It's just one possible solution, minus 6r squared. On the right side, 6r squared minus 6r squared is 0. On the left side, 4r squared minus 6r squared is negative 2r squared. And so we'll rewrite negative 2r squared equals 6r. Okay, and remember that's 6 times r. Oops, you can't see it. Okay, well, we still want to get the r's together, and we want to get everything else away. All right, so there's multiple ways to approach this, but here's one way. Let's get rid of this negative 2 on both sides by dividing by negative 2. Okay, that cancels on the left, and I'm left with r squared equals 6r over 2, and we put that negative sign out in front of the fraction, just like that. Okay. Well, now what do? Okay, we got to get rid of the r. So I want to divide out the r on both sides. All right, so I'm going to divide out the r on both sides. So I'll divide by r on the left, and I'll divide by r on the right. Okay, so on the right side of the equation, this is going to look a little bit different. On the left side of the equation, we'll rewrite r squared over r, and hold off on applying the quotient rule there. And that is equal to, and this is how I want to write this. I want to write this as negative 6/2 times r times 1 over r. Okay, that's the keep, flip, change principle. So we're dividing by r, so we'll multiply by 1 over r. And that allows us on the right side to cancel out the r's. Okay, so on the left side, we apply the quotient rule. And remember, the quotient rule would say r squared divided by r. That's r to the first is r to the 2 minus 1, which would just be r. So now r equals negative 6 over 2, and that is just negative 3. Okay, so that's how you solve those problems. So let's do another one. We're given 4 of these. So we did the first problem in that section. Let's do number 4. That's the second problem in that section. And here number 4 tells us 1 is equal to, big fraction bar here, k plus 2 in the numerator over k plus k plus 1 in the numerator over k. Right? And it says solve for k, basically. All right. So the first thing we do is notice, hey, I've got common denominators here. I can combine these. Well, how do you combine them? One way is to stack add. Okay, this is it's the same as addition, but it's with letters and numbers. Okay, watch how I do this. And I'll certainly teach this. I'm giving a little preview here of doing this ahead of time. 2 plus 1 is just 3. Okay, plus 3. And k plus k is 2k. Remember, I'm not multiplying. It's not k squared. It's just k plus k. And remember that there's a 1 in front of the k's. So I just say 1 plus 1 is 2. Bring down the k. So 2k plus 3. Let me rewrite this now. I've got 1 set equal to 2k plus 3 over k. And the question is, now what? Okay. Well, there's multiple ways to approach this right now. You could turn 1 into a fraction, say 1 over 1, and you could do a butterfly method, or you could simply get a common denominator with k, right, on this side of the equation. So because I did the other way in problem 3, I'll show this method here. Basically, what you want to do is multiply 1 times k over k. And that's because in order to get k in the denominator, which is where I want it, I have to multiply by 1. So k over k is just 1. And here's how that looks. So k times 1 is k over k. And now I have a common denominator. So I'll just finish rewriting this. Equals 2k plus 3 over k. And again, now the question is, now what? All right, well, we can subtract from both sides k over k. And remember, this is one of many ways to do this problem. There's not like a right way or a wrong way. There's just ways. So anyway, k minus k is, or k over k minus k over k is just 0. And then on the left side, I can set it like this, minus k over k. All right? So remember, if k is by itself, there's just a 1 in front of it. So basically, here's the problem I'm doing in the numerator. I have now on the left side just 0 equals. Okay? Everything is over on the right side right now. And I've got to do this subtraction, 2k plus 3 minus 1k. So here's what that looks like. 2k plus 3, and then we'll subtract 1k. And it's really important that you line it up when you do this. Let's see what we get. So 3 minus nothing is 3. Okay, so it's still plus 3. 2k minus 1k is 1k. So it's just k plus 3. So now I have 0 equals k plus 3 over k. And the question remains, what do we do next? And what we do next is we'll multiply out this k, right? So I'm going to multiply out the k on both sides. Well, on the right side, the k's cancel, and on the left side, k times 0 is still 0. So I now have 0 equals k plus 3. Okay, so I'm almost done. I just have to finish this problem by subtracting 3 from both sides. And I get negative 3 equals k. Okay, so if you work this out another way and you got to negative 3 equals k, if that way was simpler for you, then great. But I want to show you that there's just a multitude of ways to work problems in algebra. And you need to be comfortable with many different approaches. Okay, you got to be flexible. So there's the whole problem. Now we'll do number 5. Number 5, we're given 5 over 6n squared minus 3 over, or rather I should say 2, it's not 2, it's 2. My eyes looked at the wrong line. 2 over 3n equals 1 over 6n. Oh boy. What do we do here, you know? Because we don't have any common denominators. So it's kind of like, well, I guess we're stuck. But that's not entirely true. Okay? Think about this. We're going to find the greatest common factor. I'm going to write this out because I want you to see this. We need to use this empty space up here. Here's what we need to do for this problem. I'm going to make some more space on my page. All right, I want you to understand that the space up here is for number 5. All right, up here. We need to find, sometimes writing it out, we need to find the GCF, greatest common factor, of 6n squared, 3n, and 6n. Okay, so the greatest common factor here is taking on a new, broader, more nebulous, more arbitrary meaning. We need to understand it in a more general sense, all right? Let me tell you what this means in practice, okay? You have to look at this and say 6n squared is the highest exponent, biggest, scariest guy among this group of 3. So the question is, what do I need to multiply by 3n to make it turn into 6n squared? Okay, and I want you to look at how I'm going to do this. 3n times 2n would equal 6n squared. You see that? And look over at 6n. What would I need to multiply by 6n to turn it into 6n squared? Well, just another n, right? 6n times n equals 6n squared. Okay, so what does that mean? Well, here's what it means. We need this information right here and this information right here. Okay, let's go back to our problem. We're going to rewrite this and give us some working space. 5 over 6n squared minus 2 over 3n. And here I'm going to stop and go to where I was looking at 3n, right here. I need to turn 3n into 6n squared. So I've got to multiply by 2n. But I can't just do that in the denominator. I've got to do it in the numerator and in the denominator. So I've got to multiply by 2n over 2n. Okay? And that is going to be its own little problem. And that is equal to 1 over 6n. And remember, we got to turn 6n into 6n squared. So I've got to multiply 6n by n. But I can't just multiply the denominator by n. I've got to multiply them both by n. And this is also its own little problem. All right, so we'll do these little problems. We just have to multiply across the top and across the bottom. New line, let's rewrite 5 over 6n squared. Do a lot of rewriting in algebra. Okay, and we'll put the minus sign here, and let's perform this. 2 times 2n is 4n. 4n. over 3n times 2n is 6n squared. Okay, so now I've got common denominators with those, equals. Multiply across the top, 1 times n is n, over 6n times n is 6n squared. Okay, so now we can gather all of the terms together under a single fraction bar, and then underneath that we have a single denominator. So how would I gather the terms? Well, let's simplify on the left first. We can rewrite this with just one denominator. Because they have common denominators, I can rewrite this as 5 minus 4n over 6n squared equals n over 6n squared. And now I can subtract n over 6n squared from both sides to get every n on the same side of the equation. So let's do that. Now on the left side, I'll do the same thing, minus n over 6n squared. And here's what that looks like in practice. We're just going to tack this minus n onto the end of the expression. We have 5 minus 4n minus n all over 6n squared equals 0. Okay? So that is the state of the problem right now. Now, what do we do to continue on, right? Well, here's a cool trick. We just multiply both sides of the equation by 6n squared. And watch what happens. On the left, the 6n squareds cancel. And on the right, 0 times 6n squared is just 0. So now all I have is 5 minus, and here we can do the subtraction. I've got negative 4n minus n. So it's going to become more negative. Remember, this is 1n. So that would be 5 minus 5n equals 0. See that? So now I will subtract 5 from both sides. Right? And I'll rewrite this. On the left side, that's 0. And on the right side, it's negative 5. Okay, so I've kind of run out of space here at the bottom of the page. I'm going to move this over. You can write this arrow to say, well, I'm going to go over here now. And so I'm going to negative 5n equals negative 5. Okay, we can get the n by itself by dividing both sides by negative 5. On the left, the negative 5s cancel out. And on the right, we see we have the same thing over itself. So negative 5 divided by negative 5 just reduces down to 1. Okay, 1 over 1. So that means, therefore, okay, n equals 1. All right? Amazing. Would you have believed that that huge, scary fraction was just 1? I would not have believed that, where that n would just equal 1. Well, it does. So that's number 5. Number 6. What wonders will you have in store for us, number 6? Number 6, we are given 1/3. I love it already. 1/3 plus, here it comes, k plus 4 over 3k equals and here k minus 2 over k. All right, so once again, we've got to find the greatest common factor in the denominator, and that's going to be 3k. All right, so I would need to multiply 3 by k and k by 3. So we can kind of edit this problem here by just saying, well, I'm going to multiply 1/3 by k over k. All right, and I'm going to multiply k minus 2 over k by 3 over 3. Be careful when you do this, especially right here. We need to put this in parentheses, and we're going to multiply this 3 on top. But let's do it from the left. K times 1 is k, so this equals, or this becomes, I should say, k over k times 3 is 3k. Remember, the number comes first, then the variable. So k over 3k plus, we don't have to do anything to this one, k plus 4 over 3k equals, now we got to do this, 3 times k is 3k, 3 times negative 2 is negative 6, all over 3 times k, 3k. All right, so now we got common denominators, and that's the key, y'all, that's the key. So we can combine k and k plus 4 over here. Remember, this is 1k, 1k. So when we add 1k plus 1k, we get 2k, and then add that plus 4. And all of that goes over 3k. Because it's the same denominator, we're able to combine it, equals 3k minus 6 over 3k. Just like the last problem, we're now going to subtract everything on this side from both sides. So we'll subtract 3k minus 6 over 3k from both sides. I know it seems like a lot to write, but you know, it's not much different than solving like a single variable equation with integers. So 3k minus 6 over 3k. And let's make sure we understand what that looks like. So I'm going to have on the left side some fraction bar here. In the denominator, I'll have 3k. And it's all going to be set equal to 0, okay, because 3k minus 6 over 3k minus 3k minus 6 over 3k is 0. So this whole left side goes away, and it's just 0. So what do I do in the numerator here? And that's the key. So over in side work, we need to say 2k plus 4 minus 3k minus 6. Please be careful when you do this, because you might miss a negative change. Well, let's do this. So follow the pen. 4 minus negative 6. I'm going to say it again. 4 minus negative 6. 4 minus minus 6. So look over here, I've got 4 minus minus 6. That's the same thing as saying 4 plus 6. So 4 minus negative 6 is positive 10. Now we do 2k minus 3k. Well, that would just be negative 1k, which is just negative k. So we can simplify this to say negative k plus 10. And now what do? Well, we just multiply both sides by 3k. Okay. On the left, the 3k's cancel. and we have negative k plus 10 equals 0. 0 times 3k is 0. So now we will continue to isolate the variable k by subtracting 10 from both sides. And on the left side, that's 0. And on the right side, 0 minus 10 is negative 10. And now we have negative k equal to negative 10. All right, so I've got to get rid of the negative. And remember, there's a 1 here. So I can actually divide out a negative 1 like this. Divide both sides by negative 1. So the negative 1's cancel, and I have k by itself equal to negative 10 divided by negative 1, which negative by negative is a positive, so k just equals 10. All right? Now, I want you to pay attention to this because this problem, especially right in here, there's a lot of potential for error if you don't take your time. All right? So please take your time with this. All right? So that problem had many steps. And you say, well, how do I ever learn how to do a problem like that? Well, you don't ever learn how to do this whole problem. You just, what you learn is, and this takes time, guys. I'm not here sitting thinking that this is just going to pop into your head. But what you do is you make a rational, logical decision at each moment. What do I need to do next? So there's no grand plan. You're just kind of following a trail of breadcrumbs wherever it takes you. Okay? So I promise you one thing. I want to tell you something. The ability to do this math problem is born out of the ability to fail to do this math problem many times. In other words, you make a lot of errors in your math until you get it in your head. It's just like anything. There, if you want to throw a perfect 20-yard pass, you've got to practice throwing that ball and fail to throw that 20-yard pass probably thousands of times before you can, in the heat of the moment, in the middle of a game, stand at the 20-yard line and throw a perfect pass to the receiver in the end zone. All right? That comes with thousands and thousands of hours of practice, and so does this ability with mathematics. It's a sport. It's like a sport, okay? But we use the pen and the protractor instead of, other muscles. We use the muscle in our skull, right? The brain. So I just, with that little speech, want to give you some motivation. Having this pop out of your head is not going to happen, but chipping away at it will bring it to you. All right? Well, that you might feel a sigh of relief at this point because the next two problems are much easier, and this is where we get into some new material. These are called literal equations. Literal equations. That's their name, but I mean, I don't know. Nobody ever referred to them when I was growing up like that. It was just watch the problem and see. You'll see what I mean. So it says here, solve m plus x equals p plus n for x. All it's asking us to do is get x by itself. Okay? Get x by itself. Well, all I need to do on the left side is subtract m, and then x will be by itself. So I'll subtract m on both sides, and m minus m is 0. So I have x equal to p plus n minus m. And that's it. Okay? That's it. You're thinking, are you serious? Yes, that's all you had to do. So these are deceptively simple, or deceptively difficult. They're not difficult. They look difficult, but they're really easy. So here's number 8. and this is the final problem in the set. We're given C over D equals R plus D. Oh, I'm sorry, I wrote it wrong. C over A. Oh, they kind of look similar. C over A, right, equals R plus D. And they want us to solve for A. Solve for A. All right? Well, how do we get A by itself? That's the question. Well, we've got to get it out of the denominator. That's for sure. So one thing we can do is multiply both sides by A. Now we need to put this in parentheses and multiply by A. Right? So watch how I do this. On the left side, the A's cancel and I get C equals, now don't distribute the A. Keep it like that. Open parentheses, R plus D, close parentheses, times A. So if I want to get A by itself, all I have to do is divide out of both sides R plus D. So you just R plus D in parentheses like this. R plus D. On the right side, the R plus D's cancel. And I've got C, we don't need the parenthesis anymore, C over R plus D equals A. And that is the answer. Okay, so A equals C over R plus D. Again, it's much less numerical manipulation and algebraic symbolic manipulation as in the 4 problems that preceded 7 and 8. But that is the problem set. You know, guys, I'm putting this video out here with all the answers. But on this set, I'm going to do a photo turn-in because I want to see the work. Obviously, the work here is substantial. And so that's why I'm giving this to you on Thursday morning. And I'll teach it on Thursday. And then you'll have the whole weekend to work on it. So I'm expecting you to spend some time with this video, all right? Because this is the final new material for this unit, and then we'll have a test next week. So tomorrow we'll learn this stuff, and then on Friday it's going to be crazy because of the homecoming festivities, but we will make every attempt to do some review with those who are there. And then on Monday you'll have a test, okay? So this assignment here, right here, this assignment, this is not due until Monday, all right? Monday at 8 a.m. So it's only 8 problems, but it might take you some time. Okay, so if this video was helpful to you, please give it a thumbs up. And if you have a question, please leave it in the comment section. If you have not already, please subscribe to the channel and hit that notification bell so you're always updated to new videos on this channel. Thank you.